take off. Right. So we now have a operator running with QGroundControl with PX4. Oh, and you can fly around a bit. Right out. All right, good afternoon, folks. I'm Rob Stewart. I work with Dr. Krishna Kaipa and Dr. Kong Wei in the collaborative robotics and collaborative robotics and adaptive machines laboratory. I do work on small autonomous vehicles. We're here because we're working on the underwater quadrotor project. All right, we're looking to install the UAV Toolbox Support package for PX4 Autopilots. Our goal here is going to be deploy PX4 on a host computer with a PX4 host target to create a PX4 software in the loop simulation. It's going to run an attitude controller for an X configuration quadcopter using external input, like a PS4 controller, which I'm just going to use. If you're confused with the PS4 host target is, you're going to be simulating, which effectively is a cube orange. This is what we use inside the underwater AUV. So you're going to be able to run this inside your computer. We're going to run the example code with basic attitude control, just going to be shifting left and right, pitch and roll control, and run through the whole setup for that, and ideally have a 3D visualization that you can all run on your machines so that you can start to design and develop stuff. So let's get started with this thing. First step is going to be, you're going to go to the MathWorks site if you've not already. We are going to need to, so you're going to log into your university account. We want to make sure, so when you go to download it, we want to have MATLAB 2024B. This is important, okay? You need the newest version. We're going to be working off of this. We're not going to be updating to new stuff because this works correctly. Some stuff starts to break depending on the versions you go with. So I have already downloaded and installed MATLAB 2024B right here. When you do it, also make sure you install all the toolboxes. Select all of them. We're going to want all of them. They're useful for different things. Let me really quick open that. Second. And you'll have to do your sign in. I will back right after I finish. All right. And I'm back. So we're logged into MATLAB 2024B. I realize, let's give a quick rundown of what we should be expecting here. Obviously, we're going to be using MATLAB with Simulink UAV Toolbox Simulation with PX4 Autopilot Support. We want to run a vehicle attitude simulation with PX4 Gamepad input and 3D visualizations. We need to install MATLAB 2024B. We're going to install the Simulink UAV Toolbox. We're going to install the Simulink UAV Toolbox Support package for PX4 Autopilots. We need to install the support package for PX4 Autopilot's Toolchain, which includes some things like Windows subsystem for Linux 2, Python 3.8.2 if I recall correctly, and then configure the PX4 environment in the Windows subsystem. Also need to install QGroundControl, and we'll install DS4 Windows, which lets you use a PS4 or an Xbox controller with a Windows device. Probably running some troubleshooting, and we'll need to run, well, hopefully we'll be running the simulation by. So my first thing here would be straight up to do your UAV toolbox for PX4. We pop up with UAV support toolbox for PX4. This is going to take you hopefully to the MathWorks help page, which gives us a bunch of information about basic concepts, stuff like that. We're just going to skip right to the setup. Okay, so we're just going to be working through everything here. So we're going to be installing the support package for PX4 Autopilots. So if you pull this up, we're literally going to go right through. So we're going to go to add-ons, and it's get hardware support packages. We should be able to search for PX4. There we go. We have our UAV support toolbox. We are going to install. It's going to take a second to find it, and it should download it. Notice we have preparing. We have our Cube Orange Plus, Cube Blue, a bunch of other different ones that we're going to want to. I am going to pause while I wait on back. Alright, after a bit of waiting, you should see the UAV Toolbox confirm selection. You're going to click Next, Accept. You're going to download your support packages. We want to set up now. Alright, so we're on the Install Windows Subsystem for Linux WSL2. The Windows Subsystem for Linux WSL2 allows the development of PX4 on a Windows computer. The PX4 Ubuntu development environment can be executed on WSL2, thus allowing PX4 code compilation for an Arduino Autopilot configuration. We're going to install Windows Subsystem for Linux on the Windows computer with the following instructions in this link. A lot of this is great because you just walk step by step by step, see where it opens. Bring that up. So we're going to follow this through as it says. So we need to be connected to the internet, obviously. Ensure. So this will need to be set in your BIOS. There's a thing for virtualization, Intel VT or AMD-V. If you do not have this, we'll have to figure something else out. So run Windows command prompt as an administrator. So Windows button, you can take CMD and then run as administrator. You're going to click yes to run administrator. Following through on this, we're going to install WSL Ubuntu 2022.04. We want Ubuntu 2022.04. It is possible to do 2004, but we want 2022. Copy and paste that command in. I'm going to enter. We're going to download Windows Subsystem for take a hot moment here. Actually, pretty quick on this. Here. For installing. There we go. Ubuntu 22.04 LTS. LTS is long-term support. This is a version that is supported for a long time. This is going to run an Ubuntu instance inside Windows. So you're going to enter a new username here. I'm going to call this Autopilot. And I'm just going to make this same thing, Autopilot. You can choose something else that's a little more safe. I'm going to change this probably afterwards, but all right. And as you see here, we actually have if anybody is familiar with Ubuntu or a .NIC shell or like a Linux thing, we are, so we are in a Linux environment. Now it looks like apparently I did not have to restart, though it's not the first time I've installed this, so it's possible that I already had it there. Let's see if we can set this correctly here. We can set the WSL set default Ubuntu 2024. I'm going to open a new command prompt, Windows CMD, run as administrator, and I'm going to paste WSL set default. Operation completed successfully. I think, let's see, WSL, that's going to take you right into the command. Let's see, I think there is Windows CMD administrator again, and I think it's WSL-V. There we go. That's going to tell you WSL version. And let's see, and there's some other helps here for setting it up if you're having trouble getting this configured. And there is a way to check your versions. Yeah, WSL-L for list, -V for version. That was what I can remember. There we go. So we got Ubuntu 2022.04 running version 2. Now I'm going to close. Oh, hey, there's a nice GUI here. Welcome to it. Do more of that on your own if you want to. We're going to close that out. Okay. And now that we're there. Okay. Installation of WSL2 requires you to have already started your computer. Okay. Setup Start hardware setup dialog box again after you complete the installation and set up the Windows subsystem. Open MATLAB, add-ons, manage add-ons, click the gear icon. Okay, it seems confusing at first, but we're going to click finish. And now close this add-on explorer. I'm going to bring it again up here. So we're going to go to manage add-ons. And if you ever get confused, you will have the link for this page. I actually have this up on another monitor. Notice we're here under the Windows subsystem for Linux. There's this Python install, but what you're going to see is it's going to prompt us to do Python anyways as part of the dialog boxes in MATLAB. And as you can see, we got manage add-ons, and then we're going to come to here, and here's all our toolboxes. And if we install it correctly, PX4, enter. There is our support package. Put the gear. Give it a second. Cool. So, Python 3.8.2 and PySerial 3.4 required to upload it. So we're going to have it, but we're going to follow this. Automatically download and install. And I'm just going to put it on this default location. This install of Windows has nothing on. So there we go. Install. Giving me a, yep, there's a you need to approve. Sometimes over the background. Viewing here. There we go, successfully installed. We're going to click next. We're going to download the PX4 source code. So this is the PX4 Autopilot source code. Same thing, bring up the link here. So, and we're just going to follow through on this. So launch the WSL2 shell. So Windows CMD, run as an administrator. Do WSL. Should boot up the default unit. So you're going to navigate to the home directory by executing cd and a tilde. It's tilde. cd. Go. All right, home directory. Cloning the firmware in the home directory is crucial. If you clone outside it, it will cause issues with things. So we're going to download the source code from PX4's GitHub. Copy that text in. Oops, copy. Here, right. There we go. It's a little character there for flavor. Alright, we got our git clone. We should be able to pull all of that in. Oop, it's you can always tab up. I think it added a tilde that I did not mean to have there. Git clone. That. There, yep. Let's try that again. Cloning PX4 Autopilot. It's going to run through a bunch of different packages, a bunch of different parts of the code base. Curious, while we're sitting here right now, you can actually navigate to this URL. And here is the PX4 GitHub. So we're cloning a version of this that we can save locally, we can build locally. Also, ultra great stuff here. PX4 has an amazing set of documentation. If you go to just search for PX4, you'll find a website here, open source Chrome developer stuff. There's a ton of information. Documentation is great. There's all sorts of stuff with it. We're going to be starting with trying to make starting with just a basic quad and then modifying it from there. So we can kind of update it with our vehicle dynamics. We can stuff here, but we're just doing the basic part here. So I'm gonna let this run actually so you can see what. Okay, and with that, you should see you return to your prompt here where you can now enter things. So from there, we're going to, after the firmware is cloned, run the below commands one by one. So we're going to navigate to the directory where PX4 is supposed to be installed. And or is that in, so cd PX4 Autopilot, and blue confirms that we're in the right location. Git check out this version. Git, oh my, it's check out D 1.14.0 dash. Miss. Oh, there we go. Yes, that is correct. So we're in version 1.4, 1.14.0. We're in a detached head state. Look around, make external changes, commit them, discard, make without impacting any branches, by switching back to the main one. This also means that you are not pushing stuff to PX4's, to the actual main dev stuff. You got to be careful with that. We do not want you guys all just accidentally sending, sending things to it to try to update it. We are now at this version. Apparently that was the last update. Tilt rotor effectiveness limits thrust axis tilting to Z effectiveness scaling. Huh, that's cool. All right, then we got to do this part C. Git submodule update. Git update --init recurve. Unfortunately, I'm on a new keyboard, or different keyboard for this machine that I'm not used to. Little type. Mic has been on. Good. That run. And if you get it stuck in any of these steps, it's possible to, sometimes you have to you can nuke the Windows for subsystem, Windows subsystem for Linux, install and restart from scratch. This is not difficult to set up the first time. And we're back here on the prompting, so we can go back to the hardware setup screen. So we can close out of here, and it says we can go back to the hardware setup screen. And we're going to click next. Now it says to verify it. So click validate, follow the instructions provided here to locate our download. I am going to create sacrilege and use Edge to pull up the thing I'm following right now. The Chrome will always show up on the main screen whenever. There we go. Okay. So locate this path. So I'm going to pull up in the command prompt again, Windows CMD, right arrow, down arrow, left arrow, enter, CD, tilde, oh, sorry, WSL. There we go. CD tilde, CD, PX4. The nice part is once this is set up, you will not be messing with it. This is a one-time thing. Gotta bear with it. All right, we're here. All right, run the command, the pwd command to print out the path value. pwd home autopilot PX4 Autopilot. And autopilot is, in my case, because I named this WSL instance, this Ubuntu instance, as autopilot. If you call it something different, that will be different. So we're going to click validate. Firmware validation successful. All right. PX4 toolchain setup includes installation of different utilities, GCC 931, cmake3.x, and certain Python 3 packages. Refer to this link. Do the same thing. So it so happens that we are still in the WSL shell. We are in the PX4. It's saying PX4, so let's see if that is correct. So cd tilde back up to the top directory, and it's going to be cd PX4, oh, capital P, PX4 slash PX4 forward slash, oh no, PX4, go forward slash. God, this is painful. I'm sorry about my typing speed here too. That is, okay, so it's, my guess is they are showing it in a, okay, that is a little annoying. They show it that way. It should just be, yep. It looks like they put it in a separate subfolder. Now what we're going to do is navigate to the folder containing the toolchain setup script. So cd capital tool slash. Cool. So that's there. So we're on the right spot. Bash dot slash ubuntu dot sh to run the toolchain script. Sudo is going to be the password you did before. I did autopilot. Files. It's installing all this stuff, and then boot the host computer. So after this, I will reboot and join you back after reboot here. All right, so there we go. We're going to need to reboot the host computer here. So we are going to, I'm going to close out of here, and I will see you guys. We are going to, we need to install QGroundControl software here. So this is a ground station control software. This is actually what we'll run the Blue ROV, plenty of stuff, different ones use it. We're going to go to download, current stable release, go to the GitHub release page, and you're going to find the one that matches your system. Obviously you're on Windows, so ground controller install .exe. We're going to open that. Yes, we want to install. We're going to install as QGroundControl. Next, install. That finished installing. All right, welcome to the UAV driver setup wizard. This is great because this is if you want to use the actual Cube Orange, you're going to need these installed anyways. We're going to accept our license agreements, put it in the default folder. All through. This computer hasn't had any Arduinos or anything plugged into it, so it still needs Arduino drivers. Install again. Click finish, finish, close, and we should now have the ground control. I'm going to open it. I'd be jumping ahead here, but ground control real quick. Sure. Yeah, we'll use that because if you have a PC, so if you have a PC, QGroundControl can act as a ground station. Can put if you have a GPS or Wi-Fi thing that can tell your location, it can actually put it on the map. So you'll have the drone where it is in 3D space or in geospatial coordinates on the globe. Looking at this here, we're going to go measurement units, use meters or use metric for everything except I'd use meters per second personally, except Fahrenheit. I'm not a Celsius person at this point, but the rest of this will be meters. We are going to use Simulink generic. Reason for this is will become obvious at a later point, and we'll just use multi-rotor for now. Yes. All right, I have a fresh Windows restart. I'm going to open MATLAB A4B. A quick review of everything that we should have had installed, where you should be at. We have run through like add-ons, manage add-ons. We're looking at the UAV Support Toolbox for PX4. Right here, PX4 Autopilots. We're going to click the gear to manage. This should bring up second here. That's going to bring up, I think here. If this doesn't, but where we've gone through is we've gone through everything under the UAV Toolbox package, setup and configuration. And we have is done all these different things. All the UAV support toolbox. We've installed the Python, set up Windows subsystem for Linux WSL. I'm going to use command prompt, Windows button. We're going to put command prompt, Windows button CMD. Command prompt, we're going to run as an administrator. And we are going to check our version of WSL, WSL-L-V. We have Ubuntu 22.04 is what we should have. We're going to then go back to, we've also should have pulled down the source code, should have built all the tool chain. We're going to confirm that here. We're going to click validate. We're going to validate. It is validated that we have it on our WSL instance. Now, the next thing we need to do is we're setting up to connect to QGroundControl. So you should have installed QGroundControl. We're going to open that. Put this right here. Next, I'm going to come into my command prompt window and I'm going to take WSL to start running the WSL machine. And we're going to type in, we're going to take a link here I have from the PX4 documentation on setting up the Windows Dev environment. This is an easy thing. And actually, I'm going to expand this whole link. This is the link. And we're looking at how to set up QGroundControl on Windows. This part here is finding the address of the WSL virtual machine. So we are going to come into here and we're going to run this command right here. I'm going to run on my machine IP addr space vertical r space rep eth0 and give me an IP address right here. Copy that, Control C. There is no right click. I'm going to come to my QGroundControl. I'm going to click top left corner, Q. Click my application settings. Go to my com links. Go to add. Because here it says that we need this IP address and then we need the UDP link for this port, which is 18570. Type a name of WSL. I'm going to want this to automatically connect. UDP port, as it says before, is 18570, and my server IP I just found. I'm going to add server. It now created a link to look correctly for, and I'm going to connect because I'm going to leave this QGroundControl instance background. Minimize that. I'm going to minimize this. I'm going to minimize the WSL window, and we are going to continue progressing with our hardware setup for the UAV support package for PX4. So from here, we're going to click next. This is to enable or disable the default PX4 controllers. We are testing just to make sure that we can actually fly it in a sim with the PS4 controller or an Xbox controller. So we do not want to disable the controller mod. We want to keep those left on. When we rebuild it later, it will override it and it will not use it. You want to keep those. Next, to check, we are going to be running PX4 Host Target, which is a software in the loop simulation that's going to run on your machine and simulate QOrange Plus that we have in the lab. So we're going to be able to simulate the real hardware with the machine on. It's going to select it, and then we're going to delete. If there's anything there, we're going to delete the previous build. We're going to build it to here. It's going to take a few minutes, and we're going to click Build Firmware. And we will wait a minute while that is. I'm going to leave this to run until it doesn't populate. Running the background. All right, so from here we had a successful build of the firmware. Next. Alright, so we're almost ready to launch the host target in jMAVsim, but we're going to do something here, which is we want to set up the PlayStation 4 controller so that we can control it through QGroundControl as a joystick input. So, what we need, because DualShock 4 or PlayStation controller does not work by default, we're going to go to Chrome. In Windows, we want to make it look like it's a Xbox controller. So we're going to use a program called DS4 Windows. DS4 Windows. I'm going to go to download. We're looking here. Right now it's on 3.3.3. Download. You may need to install a .NET runtime. I've already had it loaded. After that, you open it and extract it. Right click, extract all. Extract. I already have it there. I'm going to do it from a fresh one so you can the things that get when you install. All. So if you run it from here, you can run without needing to be installed on your machine. We're going to put it onto the program folder. We're going to use DualShock 4 support for the DS4, and we're also going to put in the DS5 support. And it closed. Should bring this up. Now, my PS4 controller is not bound. Hit the Windows button or click the Start menu. Go to Bluetooth. Bluetooth and other device settings. Go to Add Device. Bluetooth. And to pair, I'm going to press the PlayStation button and the Share button. Hold those together. If I do it right, I should see rapid blue flashing on the rear of the PS or the DS4 controller. There we go. We should now see a wireless input. There we go. You can also now see blue, and under the controller image, we actually have controller 1 is using profile default. Done. I'm going to click that. Bring it up here. I can actually see the blue. Shows me that I have it. I'm also going to go to edit, and you can confirm my controller readings. Move the sticks, getting movement. Go to other. I can see I'm emulating an X. I'm going to keep this cancel. I'm going to minimize that. Done with these windows. The Explorer windows. Done with DS4. Minimize that. We're now back to here. We are going to pop open our QGroundControl window here. And I'm going to launch PX4 Host Target and jMAVsim. And we should start to see some command windows popping up. And you can see it pulled it up in QGroundControl, connected over MAVLink, and now I have simulation here running in the 3D jMAVsim environment. And one of the things we need to do now is go to QGroundControl. We're going to go to our vehicle setup, joystick. You can see we have our Xbox 360 controller. I can move my sticks. I'm going to go to button assignment, and I already set this before, but we're going to want our share button here. Press it, you can see that the 4 lights up. 4 lights up. Go to arm. 6 is our options button here. I'm going to set that as disarm. That's all we really care about right now. We could map other things if we want to, but we don't do that. And we're in RC mode 2. We're going to go back. Now we can see we have ready to fly. I can hit the top left corner share button. We now have the vehicle is armed in the sim, and I'm going to go up with the left stick and take off. Right. We now have the operator running with QGroundControl with PX4. So, and you can fly around a bit, try out some. In jMAVsim, you may be wondering what you can do with it. The big thing you want to know is the F1 key. There's no menu without it. F1 equals a menu. Yep. So if I click here and I press F1, get a pop-up of all the menu options. You need something you're curious what something to do. There's different, there's first-person view, the stationary ground view. So with that, anything else to show off? Yeah, we can fly around. We have the back here is the jMAVsim build that's running, and this is actually the PX4 emulation that is then feeding in jMAVsim. So down with the stick. Typically, when you take off, north is more or less away from you. So the red should be towards you. Blue is the front of the vehicle. It's going to be important here in a minute because we need to confirm. You always want to confirm that you're reading in your inputs correctly. You do a sim. Drifting a little bit. And unfortunately, you can't actually disarm, because once you start flying, the vehicle does not recognize a landed state. Oh, I take it back. There we go. It did actually disarm. Cool. So that is our initial sim test. Pretty cool, isn't it? All right. I'm gonna that's the part we want to stop there. Actually, no. Let's move from. Okay, so let's move into actually running the full. We want to. Okay, so you notice we lost connection to the vehicle because close the sim out, or close everything out. It's going to lose connection here. This should say it's not running. Yep. So now, also, we're just going to hit disconnect. We're going to leave the QGroundControl up because we're going to use it in a bit. Get that out of the way. So if we click next, we'll notice that it says we're now ready to use it. Hardware part is correct. So we would show some examples, but we actually know exactly which example. We're going to come in to our setup and configuration, go to examples, back one. I'm going to go to Toolbox, header, and find the example here. Scroll down, and we are looking for deploy PX4 on host computer with PX4 target, and we want this attitude configuration, attitude control configuration quadcopter using external input. We already knew our external input works, so we're going to click on this, and we're going to kind of do a little following along too. So, obviously, didn't know what Simulink is. If you're still confused, watch the quick start video. We already know that we've done the setup and configuration tasks. Just here. We have QGroundControl installed. Now we're using a game controller that works. We're going to open this PX4 demo code. You can actually, or model, we can click copy command. I'm going to go down to the MATLAB workspace, default workspace. You know, this is actually when we built that last model. I'm going to use CLC to clear screen. I'm going to paste in open example of this, and I'm going to hit enter. Take a second and loading that up. So we're loading up a attitude controller. We have PX4 read, a UORB read that's going to read that joystick input, the controller input, game controller, not the same as the attitude controller. Game controller, gamepad input from QGroundControl. It's then going to run it into here into we have a Z, which is going to be our thrust, our altitude. X and Y is going to be slide slip left, slide slip right is our roll. Right there, there's our roll. Our pitch is forward and backwards, and our yaw is left and right. So our model is open here. I'm going to pull this up here. If you press spacebar, that will full screen it for everything. Now, there's a little bit of reading you can do in here. Talk about how this is set for the configure the read input. Then we're going to read the vehicle's attitude and design a controller with 1 degree of freedom PID loops or PID control. So we're going to control the yaw angle, pitch angle, and roll angle. All right, yaw, pitch, pitch, and roll commands are going to be controlled by a PID controller, each as an individual 1 degree of freedom control. So to access these individual blocks, you double click on one. So we're going to double click on the attitude controller. Same thing, spacebar is going to maximize it. We have our yaw rate controller. There's a PID controller right here. Proportional, integral, derivative. Enough, there's no derivative control on the yaw. We have saturation outputs to limit our total output. Our pitch controller already has some values predefined, does have a derivative gain. And our roll controller also has some values already input with slightly different limits, upper and lower saturation limits. And so as we look through this, talks about how it works. We're taking a quaternion value and turning it into rotation angles, or Euler rotation angles. We have that attitude control subsystem, which is just referenced. There's these values here. Reading. We are referencing a standard airframe, which should be the way our underwater quadrotor works. One of the things is we want to keep, the reason we keep the X in, keep it orthogonal, keep all the on an orthogonal frame, is it makes the motor mixer very easy because it's from a center of 0. If we move them into odd parts, we need to start to tell it where those motors are. So we're telling it location and direction of rotation. You can see that the location and direction of rotation, and this is how. So if you had 6 motors, you'd have a mixer that would add extra rotation. That is, so if you go up a level here, we have our here is our mixer, and then this actuates the individual motor. If we were running this on, we could run this on our PX4 or our Cube Orange Plus, and our outputs here. We have outputs, probably not going to focus, but 1, 2, 3, 4. That would be the 1, 2, 3, 4. That's what these motors are. So that's what these motors are. We are controlling. So this is simulating, actually controlling, just with a software in the loop target. That here. So we're going to run the model on the host controller and start the jMAVsim. We already know that works, but follow this through. Click this here. Windows right arrow. Windows button right arrow. Let me pop that up. I can close that, click that button, and I can move this over a bit. Too much in the way. And then Windows arrow, Windows button left arrow. Right here, we want to go up a level, spacebar. Okay. We're looking at, in the modeling tab here, we're going to click on model settings right here. In the configuration parameters dialog box, we want to go to hardware implementation. Taking a second to load. We should see here is PX4 host target. That's a software in the loop simulation of the PX4 flight control. Notice we can click a drop down here, and we have, there's our Cube Orange. If we wanted to send to real hardware, that's what we would. Furthermore, we're going to check here. So selected PX4 host targets, and we're going to check under target hardware resources that we're going to build, load, run. Software in the loop PX4 software loop default, and simulator is jMAVsim. Then we're going to go to hardware, and give you 2 options. We're going to hardware tab. We're going to make sure that our mode is run on board. We're going to click, we can click build, deploy, and start, and it'll run it. But what we're actually going to do, what we're going to do here, the interesting is we can do monitor and tune. This will run the model and then let us modify values in here in real time to see, to change gains and things. So we're going to, that is this option right here. So we're going to click monitor and tune. It's going to run for just a bit. Preparing to run the model on that. We should see some command windows, possibly Click View Diagnostics. Give you a little readout to give you an idea what it's doing. Remember, we've already, our joystick settings should have been saved before in QGroundControl, but we will, if we can get this up and running, we can see that jMAVsim view. Give you a real-time idea of how long this takes to compile. When you build stuff like this, when you build Simulink models like this, blocks cannot be added or removed. You cannot change relationships between things. You cannot data paths or anything like that. You can change gain, change multiply, or if it's constant, you can add a constant. So there's gains in here that we may tweak. You can change the PID values. There's our PX4 starts running. There's the start of the jMAVsim. All right, our quad is up and running. And if we go to our QGroundControl, ideally, a little bit of stuff bottom. Right, it's may need to go because it was spend a bit of time. Some of it times out. Yep, going to connect back, and there we go. We are connected here. So same thing as before. We're going to check and make sure that we didn't have anything overwritten. Sometimes they can be. This did not get overwritten. We're good. And we're going to go back to here, and we're going to use our arm. Let me back for. So we have arm button on share, and I'm going to up click, and you're going to notice it's going to fly very differently than before. The other thing is we're going to have something interesting happen. For whatever reason, the default inputs with the PlayStation 4 controller are backwards. We're going to try to figure. I'm going to hover and we'll figure out what is reversed where. So as I hover, remember the blue should be the front. It all works correctly. All direction is. And I think zoom is. So now if I try to roll, that is rolling. Notice it's pitching. So somehow our pitch and our roll inputs from the PlayStation controller, the controller here, are backwards. Give you some idea. We can come and check that we did it correctly. As you notice, we have our buttons here to show what is inputted where, and that is definitely pitch. It should be pitch. It's definitely roll. It should be roll. Take off, and you can see that rolling is actually. I think I came down too hard and good. So what we're going to do is we're going to stop the simulation, close out here. And this is going to have an error. It's going to disconnect. What I'm going to do next is close QGroundControl for the moment. All right, let's look at our model. We have our roll comes in here, our pitch comes in here. We've got a couple different places that we could handle this, but what we're going to do is we're just going to disconnect there, disconnect there. In fact, you can see that that is roll and that is pitch. So these are crossed. Cross those. Maybe not. And so with that, then we are ready to rebuild our model, right? Because we're now should be reading our pitch from our pitch input here. So from that, we should just be able to, this error was just because I closed out, should be ready to monitor and tune it, rebuild the model. Second. Really cool stuff I can show you after too with, or I can do a little bit of live tuning. See how powerful this is to monitor and in the loop be able to actually tune your PID gains. You can hit your pitch, roll, yaw gains. You can give it more authority, less authority. You can see if you can more response, less response. But we just want to make sure that our control inputs are coming in correct, because a cross feed on that is not correct. So we're probably going to need to go back to our application settings and check that we're connected, and we're not. So we're going to reconnect. There we are. We're connected. We're going to double check that our joystick is set up with our arm on 4 and pitch and roll. Get that back. Pitch. Correct. Go back. Forward. Then we're going to come to here. And let's see. I'm going to do a little takeoff. Oh, let's see. Oh, we got some weirdness. So blue is away. Blue is the front. What I'm noticing is one of the things is plus. Click in this window. Click in the jMAVsim window. You can use your plus to change your zoom. As it goes far away, it's not going to get as far. Let's do a little check the direction of controls. If I come forward, I try to go to the right, which is where I should be. It's actually backwards. I can tell that I want to correct back that way. Quad needs to go to the left, and I'm going to push the left, and our heading is heading. It's rolling to the right. So our roll is backwards. I also say that our pitch is. What's really cool though is that we can actually come into our UAV toolbox. Notice that our time is running. So our attitude controller is still here, and we have a pitch gain at this value here. I'm going to come in and I can actually make this pitch gain -50. That's now going to reverse that controller input. I can also take and roll gain, and I can make that +50. From there, we're going to go back to our sim here. We're going to go back to QGroundControl. Now should be able to throttle up. Oh, that didn't look right. We didn't like that. We have put it into crashed. Oh, we need. I think SOL on that. Okay, so we're going to stop that sim, and I'm going to stop that and rebuild. It might have been too much of an input too quick. That can be one of those things that's dangerous. Is what you really want to check. I probably should have lowered those pitch controller gains, but we'll just rebuild it again. Oh. We're going to rebuild this. Say that we're connected. We're going to disconnect. Oh, that's why it keeps connecting. It's going to disconnect. So I'm going to keep that connected, building it again. Yep, it'll auto put up. Should be here. Clear any messages. Technically, no error messages. And I'm going to click into here to +++ just to. You notice my zoom is there. Is to keep it close. And let's see, throttle up. Side. Pitch forward is now pitch forward. Roll right is now roll right. It's a little sensitive. You notice it will level back out. Go a bit. So I'm going to bring it down. Now let's try to see if we can do a little on tuning. So come into here, and I'm going to pull up our roll. Roll is pretty easy to see left to right. This is going to bring up our PID block, the proportional integral and derivative control. Proportional is going to give us how much multiplier. It just adds more force to it. Integral is going to try to get to that set point and correct error, and derivative is going to add a smoothing. Let's see a little more responsive. So I'm going to take off, draw a bit, face away from us, and I'm going to give a little left. See how quickly it responds. Noticing it's so now I'm just going to let's double it. All right, 50. We do a little trying to system characterization identification. It's never a good idea to change too fast, too quickly if you don't know how it's going to respond. And I'll see if I can tell a difference in connection. I don't see that just a little flick of the stick to the left is absolutely. Oh yeah, that's faster. And so that is our software in the loop with the ability to monitor and tune. I do not know if we were running scopes, you'd be able to see. Finish up here with these instructions. They have some cool stuff here where you take so monitor and tune. We can use real-time data logging, and let's see how they want us to do method they're using. Data inspector. Oh yeah, here we go. So here's our role. Here is our that's my command. Helpful to have visuals. Need to figure out what the rest. Oh, that is. One of those, I think that's a data read. All right, so these are the command inputs. It does not look like we added in a logging value. We want to, yes. So those are just my inputs. So let me stop this here, and should be able to take the pitch angle and roll angle. I'm going to right click and I'm going to log selected signals. Click this. Put your mouse over, hover over the triple dots, log selected signals. And we also want our, might as well do our yaw there. And then we'll take our roll, log that, take our pitch, that. Remember that that is actually backward. So to stop logging that, select it inside the here and pull it from our pitch. Yeah, we're feeding in our design. So we're going to take and use this. It's going to be in degree. So I'm going to take and grab the little icon there. Go up. Should have, I'm going to close out. No longer monitoring. This, close this. Rebuild our model again. Pretty cool stuff here. We got a lot of interesting examples to work with. You can, right now we just have a quadrotor, but somebody can be working on, might be something graduate students work on, is improving the simulation dynamics, because this is just the controller for a simulation of a quadrotor. Well, we can go in and modify the simulation and then feed you guys those values, feed you the visual one that changes the math underneath that, so it performs more like the vehicle dynamics of sub underwater, especially with the response rate. And the cool part is we'll be able to run the same test, run the same inputs, and see how it would respond to a real world. So we should be here. We are right back into our QGroundControl. I'm going to go into our data inspector, and yes, we now have a bunch more stuff that we. So we're going to compare. Let's compare desired pitch to roll angle. And let's ready to arm button. Oh, can't see that because try a lot of windows. Keep them off. So if I arm, take off. This is roll angle. So we want to compare roll to roll. North, it blue is away. Oh, I think I had that higher roll gain. I'm actually is that? Oh, pitch. I desire pitch. There we go. Hey, that's what. So you can see how close tracking or how close it's lagging behind. That's a great one, right? And if we come to here, screen that. To okay. Take a see. There's my commanded input. In the desired roll, there is the quad trying to match that. And if we do, if I go and change that roll gain, sorry, the PID gain for the roll back down, I now have is the ability to try to fly it again, kind of similar, and this is where reprogramming in methods and ways to test this repeatedly without the human input, or even record an input and replay it back. We want to fit you in. There we go. Now take off. Oh. I lost track of which way I was heading. Oh, we can see the pilot error right there. Been recalibrated. I didn't realize I was turned around. Yeah, that way. I thought it was pointed. Calibrate here and grab. What you can do is you can compare how quickly it gets to where it is. That is not a great example, but there's a lot of cool stuff there. A lot of cool tools, a lot of stuff in this toolbox to work with. So hopefully I can get you guys started, and that should be something that can help you with all the stuff you need. You got a lot of cool stuff to work on. Pretty much set up for it, so that should be it. Let me know if you need any help, anything else.